In the previous video, we touched upon the general definition of probability and its axioms. We defined the probability of union of events as the sum of the probabilities of the individual events, given that the events are mutually exclusive and collectively they form the whole sample space. In this video, we will discuss three useful properties of general probability that will help us in solving complex problems. We will also prove these properties using the general definition of probability. Let's get started. The first property states that the probability of the complement of event A is equal to 1 minus the probability of event A. Let's say we have a sample space S and an event A inside the sample space. The complement of event A would be everything outside of event A and inside the sample space. Since both A and a complement are mutually exclusive, we can use the general definition of probability and define probability of a union. A complement as the sum of the probabilities of A and A complement. Since A and A complement together form the whole sample space, we can replace the probability of the union of A and A complement with probability of the sample space, which, as per axiom 2, would be equal to 1. Rearranging the equation, we get the first property of general probability. The second property states that if event A is a subset of event B, then the probability of event A is less than or equal to the probability of event B. Let's say we have a sample space S and two events, event B and event A, inside the sample space. Here event A is a subset of event B because it is completely inside event B. We can try applying the general definition of probability to prove this property, but that would be wrong because the events are not mutually exclusive. Clearly there is an overlap between event A and event B. So we need to find another two events that do not overlap with each other. Looking at the Venn diagram, we can see that there is an area inside event B, but outside event A. This area is called the intersection of event B and the complement of event A. You can deduce this visually by subtracting the area of event A from the area of event B. Another way of wording B, intersect, a complement is by saying everything that is in event B and not in event A. Pause the video here and try to make sense of this visually. Feel free to rewind and watch again if you need to. Since both event A and B intersect, a complement are mutually exclusive, we can use the general definition of probability like this. If you observe closely, union of event A and B intersect. A complement is nothing but event B. So we can replace the union of event A and B, intersect a complement with event B. Clearly, the probability of event B is greater than or equal to the probability of event A, because P of B intersect a complement is a non-negative value. Hence, we can write the equation like this and rearrange it to get the second property of general probability. Finally, the third property states that the probability of the union of events A and B is equal to the sum of the probabilities of events A and B minus the probability of the intersection of events A and B. Let's say we have a sample space S and two events, event A and event B, inside the sample space. Once again, even for this case, we cannot apply the general definition of probability directly because the events are not mutually exclusive. But like before, we can union event A with the intersection of event B and the complement of event A, as they are mutually exclusive. You can visually see event A does not have any overlap with the intersection of event B and the complement of event A. Please pause the video here and make sure you have understood why this is the case. Again, the union of event A intersect event B, and the intersection of event B and the complement of event A is nothing but event B. Hence, we can replace the union of event A and the intersection of event B and the complement of event A with event B. Also, the intersection of event B and the complement of event A is nothing but event B minus the intersection of event A and B. This proves the third and final property of general probability, and with that we will end our discussion on counting outcomes and general probability. In the next video, we will introduce the concept of conditional probability and see where it fits in the grand scheme of things. If you have found this video helpful, please like and subscribe to the channel for more such content. Thank you for watching.